Good morning, everyone. Easy Jeezy here. We're over at Chill Plant 1, and we're probably going to be running these chillers today, but I wanted to show you a little project I've been working on. Last year we had a video up on replacing the front bearing on this 125 horsepower electric motor, and we recently started developing some leaks and decided to get into the seal. I tried to get some information from the manufacturer and wasn't too successful. I didn't really call and physically talk to anybody. I'm sure they would have done justice to them, but I didn't have any literature on it. It's a horizontal pump. It has seals on both sides of the pump. This is the drive side, and so I kind of figured this out on my own. I did successfully through email contact them, and they give me a price for the replacement seal kit, which included sleeves for the shaft, stainless steel sleeves, O-rings, gaskets, etc., etc., and it was like $3,500 per side. And I wanted to see if I could figure out a little bit easier way to do it, and maybe document this so that you could attempt it yourself if you get in a similar situation. And I'm going to try to, I'll have to post some pictures in here from previous video. This is the old seal, and this is the sleeve. It's an assembly that comes out, and you'll see that the mechanical, the pressure side, is it's all made out of stainless steel, and there's your springs, but all these springs are on the water side, which I think was the most of my problem. There's a cooling line for this seal that attaches to that brass fitting, and it goes up here to the top of the pump. And this pump, by the way, has been in service since about 1998, maybe later, early 2000s, and that fitting was partially blocked with crud. If you can see how this pump is laid out, this is the suction side on the right, and then it comes in and it goes out the discharge side. So the seals, if you look at this impeller, the impeller's buried inside. If you can see the impeller in there, this is the suction side. So it's kind of a low pressure area. The system pressure here during operation, the static pressure is about 40 psi. Just to kind of give you an idea here. And it's 11 3/4 inch impeller, probably cut back, and I think this pump puts out about 3,000 gallons a minute. And so let's take a look at this assembly here. There was an O-ring that went around the shaft. It looked like this. This is probably the old one. No, I don't think it is. I went to a hardware store and tried to find one. This was Viton. The actual dimension that I needed was 2 1/4 diameter to match this shaft, and then to get the proper O-ring diameter here, I needed, what was it, an 1/8 inch O-ring, and all I could find was a 3/32, and I thought, well, there'd be enough give to get this sleeve over it because it's got a beveled edge on it. It didn't work. I had to order the the proper size O-ring. You could probably tell just looking at the package here that these are the actual 1/8 inch, so 1/32 less in diameter, and the shaft does slide over it lickety split. All right, let me change position here and get set up for another shot. I'll give you another overview here. I'm probably going to set you on this little chair here, and here's my easy bake oven. that I'm heating up the outer bearing in. I'm going to reuse the old bearing. I've repacked it with grease. There is a seal on one side, and I'm going to have to turn this thing up. It doesn't look like it's making heat yet. Okay, there's the seal. And you see that Dawn dish soap there. When you're working with these seals, there are O-rings and there are things that you need to slide around, and you can't use, you're not supposed to use any type of silicone or grease or those type of things. I have personally found that Dawn dish soap works just fine. It doesn't matter if a little bit gets on the seal face. It doesn't seem to hurt anything. The water environment will wash it right out. May have different effects in different situations. Now, here's the new replacement seal. Here's your carbon ring, and it's got an O-ring on the back for a seal. Then you've got your sealing mechanism and sealing surface right here on top. You can see how highly polished that is. That has to be within 1/10,000th of an inch. That may be one of the reasons why this thing costs as much as it did. This is a replacement. This did not come from the manufacturer. The one from the factory had a name on it. I don't think it really makes any flow serve, and I think this was made, or I ordered it, got it from US Seal. It was only $900. So by reusing the old sleeve and buying that $1 O-ring, I think I'm going to save us some money and get this thing back online. I brought this over to show you an example of a similar type of mechanical seal that we use at Chill Plant 2. And the difference here on this seal assembly, this is on the water side. On the newer pump, it is a vertical shaft, and the seal is in this position with the other part being pressed in, and it goes like this. Then you have these little tabs that go in these slots so that you can load the spring and put it in place, tighten it down, and then pull these clips out, and you will get the proper tension on the sealing surfaces. On this one, they do it a little bit different. This is older technology. You have the sleeve that goes over the shaft and is sealed. Then you've got your inner carbon seal, O-ring sealed inside there, pressed and bottomed out. Then you've got your, you can see it right there, and this one was leaking. It doesn't look that bad, but the problem was, and all the rust and debris that was caught in the springs because it was on the water side. I was going to go ahead and put this back in, but I've had this thing together and apart a few times, and I think it's going to leak a very small amount, and I'd like to have it totally dry. The pump does pump chilled water. It is insulated because it will sweat in the summertime. So, but we were getting water on the floor, and I want to do it right. So I'll turn you back on when I get you set up, and you can watch me put the pieces together on the pump. For right now, I'm going to swap over these two pieces and install it, and it does not give a specification or spring tension that I can find, and I've talked to several seal people, so I'm going to use the old holes. There's a mark on this sleeve from these set screws, and that's what I'm going to use to set the depth of this part of the seal. Then when I put the rest of it together, I will push down, and these Allen screws go through this collar. The collar would go down, and this is what you got, your offset screws here. Two of the screws are going to go through these holes, and then the other two are going to go to the shaft so that it can't, the sleeve won't spin on the shaft. And this assembly will turn, but it turns at the same speed, putting pressure down on the sealing surface. So hope that makes sense, but I'll let you watch me put it together here. Alright, let's get started with this puzzle. You want to clean all your gasket surfaces. You want to use a tap and chase out your threads so that you get nice torque. And you want to put some never sees on your bolt threads. You can reuse all the bolts. I'm even reusing the gasket. And this first piece right here that we're putting on, basically what this is doing is filling up the space here. This all comes apart so that you can enter into it. You can see these other bolts around here. So what they're doing is just changing the shape down in size, and this is the next piece to go on. So I'll show you when I got it bolted in. Reusing the gasket, no sealer, putting it together dry. You could put a little grease on it if you like. Okay, this was the tricky part here. This is the old carbon seal. That's the sealing surface and the O-ring. This is the sealing surface. The O-ring goes around the back part here. I had to dig that one out of this metal retainer and get the new one in. And I used this Dawn dish soap. And the book says to take a alcohol swab and go over the seal surface. What I do is to put, when I'm applying pressure, is I put the piece of cardboard that was in the package with it on it, and I push on that. But it's usually, you don't want to put pressure in one spot because it is carbon and it's very hard, but it is brittle. And it is very expensive, and you can't buy that component separate. So I took this other collar and I put that over the top of it, and then I was able to use my palm of my hand and spread it out. And usually it's tricky, and I always get nervous. And there's a little bit of a gap there, and there's plenty of soap down in there, and the gap seems to be pretty darn even. I might measure that with a feeler gauge and apply a little bit more pressure, but I think it might seat itself when the spring plate and the other side comes into play. I'll turn it back on a second. Wish I had a tripod. Okay, I got you sitting on a box here. Now, here's the old seal on the sleeve, and there's two set screws that hold it in place on the sleeve, and then there's this top part here that does have an O-ring underneath it. It's right underneath here. That's what seals it. On this part of the outer part of the sleeve is that O-ring right inside here. Okay. Then you take your sleeve off. The spring, this is what creates the tension. So we already have out on the pump, we already have a O-ring, a new O-ring on that. And the new seal comes with an O-ring. So what I'm going to do, and this is stainless steel. This was pretty messy looking originally, and I cleaned it up with a Scotch-Brite pad. So now, same type of thing. We've got this rubber seal. So I'm going to take a little bit of soap, dish soap. Do not use grease or silicone unless it comes with it and tells you to do that. Most of the time they don't say anything, but this has never let me down yet. So now, press this down as a unit. I'm going to take this, I'm going to take one of the two Allen retaining bolts. Oh great, this one's a different size. And there's a whole bunch of them. This one's got 1, 2, 3, 4 of them. So it's probably metric. I got to get a different wrench, and I'll turn you back on. I hope I got all this in. Okay, what I've done is taken some of the dish soap and I put it on the O-ring, and I'm setting the mechanical side down, not the seal side. Here's the sleeve. It has a bigger taper on the part that goes in first. So I've got some soap on that as well. And it pulls pretty nice. Now I'm going to look for the marks for the old set screws. There's one right there. I'm going to move this up and in position. Very precise the way this thing is made. Okay. Looking for the old Allen wrench marks. Since I don't have a specification for a measurement and I'm too lazy to do the math, as I put these together side by side, the old one and the new, they appeared to be exactly the same in every way except for those contact surfaces. So now I'm looking for that little mark. I'm going to center it as best I can with my eyeball. Put the new set screw in here. I'm going to tighten it a little bit. I'm going to roll it over so the sealing surface can't come loose. Do something stupid. And I'm just going to go around gradually. Don't crank down just one spot. Just like putting on a cylinder head or something. You want to do it gradually. You don't want to deform or distort anything. These are all stainless steel parts here, so they're going to be pretty hard stuff. Okay, go a little bit more. The original one did just fine all those years with just 2 of them. So having 4, and they're going to bite just a little bit, and that's what you want, but you don't want to see how strong you are and really crank it. Just snug them in there good. Okay, now the other part of this, I'm going to, now you can use an alcohol swab if you want and wipe off the sealing surfaces. There's a little bit of soap smudged on here. I've tried to keep my hands clean and put these gloves on. You don't want to scratch this up. Don't push hard. You're just trying to get microscopic, you know, use the cleanest rag that you got that's cotton. Don't use anything abrasive. You could use a alcohol swab out of the first aid kit. Just tear one of those open and the residue will evaporate. You know, it'll come off on the swab and the alcohol evaporates. So now what we've got to do is observe these 2 holes. This is just going to, this is your sealing surface. It's embedded in here. So now the 2 sealing surfaces are in contact. Now what we got to do is take these 2 set screws, and this is how we put the pressure preload the sealing surface, is what we're doing here. So I'm looking at it. Maybe you can help me. Tell me when that lines up, would you? Okay, so I got to push down like that. What we did is line up the 2 holes on the sleeve with the 2 set screws on the collar. I bottomed those out. They don't protrude past the sleeve. Our new seal is now assembled as a cartridge, and we've got contact, we've got sealing, and everything's tight. So the next step is to utilizing this beveled edge. We want to, and I've already got soap inside here, Now we take this part over to the pump, and hopefully the other piece, I'm going to set you over here on my makeshift stool. Gosh, how's that? Okay, so I'm going to put my gasket in place on this. Slide this position. Kind of feel your way along. Okay, we're over. That was the O-ring that was on the shaft. Now that's in position. Now I'm going to loosely put these bolts in. They've got some never sees on the threads. The threads have been cleaned out. Cooling line. I'm going to shut you off for another second here. Okay, next thing we're going to do is put our bearing plate on, facing towards us. That doesn't have a seal. We got our bearing. One side still got the seal in it. The other side goes towards the grease zerk. Sorry about that. We're going to tap the locking nut into position and pull down one of the tabs. Doesn't have to be super tight. Just needs to be holding things in place. I don't know if I lost you or not. Alright. I'm using synthetic marine grease. I did wash out the old bearing with solvent. And the next thing to go on is this piece right here. And I've got to let that bearing cool completely down because it's a friction fit inside this hub. So I'll turn you back on a little bit. Okay, I think our assembly is complete. You lift this housing in there. It slid over the bearing. It was a friction fit, but I didn't have to use force. You let your bearing cool and keep this housing in a warm spot. If you get it perfectly straight, it will slide right over the bearing. Then that plate that we put on is captured by 4 bolts to hold this, and the grease goes in the side and into the open side of the bearing. These bolts here, finger tight, everything. Put these in finger tight first and then tighten them up later. Go in crisscross bolt tightening sequence. Don't have to use a torque wrench in my opinion on this job. And this sealing line, and I think this was the culprit that really caused the seal to fail. In the off season, or if you have some downtime, it would be beneficial to check these lines and make sure that they're clear. I don't have a shutoff on this line, and I think they intentionally do that or built it this way so that it couldn't be inadvertently turned off and left off. Maybe the off season you got water, a weeping seal, and the water getting on the floor. Somebody comes by, says, oh, I'll shut this valve off, and then somebody else starts the pump, and now you're starving the seal from cooling, and you'll have a failure. They do make cyclone separators that you can put in line. I have those on my condenser water pumps at the other plant, but this is a chilled water loop. It should be fairly clean. And we're going to get some water back in these pipes, bleed the air out, and test fire it here, see what we got. Well, this is a stroke of luck. Just as I'm putting the final words to this thing, the pump next to it started, so I told him, I says, hey, let's put this thing to the acid test right off the bat. And we're going to circulate some chilled water here. We got 26 pounds on the suction side.
Alright, good, I'm gonna that chill now.
Okay, well anyhow, thanks for watching, liking, subbing, and commenting. Hope this helps somebody. If you like this video and you like restoring old cars, check out some of the other fellas in the garage gang. Listen to these sounds. That wasn't good. Oh, it stayed on. We got a McQuay chiller here, and it's kind of overcast and cloudy, but it's been fairly warm. I know some folks around the country are getting a lot of snow that they don't normally have, but there we go. These are the expansion valves on the bottom of the evaporator. This is a 2-compressor chiller. It's been pretty dependable. There goes our condenser pump over here. And we have a liftoff. Well, cool. Hope everything in your day goes good. Looks like things are good over here. Let's see how the floor's doing over here. I don't see any water spraying out. Nice. This is one of those new flashlights, and the beam strobes makes that collar look like it's on crooked or stopping. Yeah. Monitor it a little bit here. Well, anyhow, sorry I held you up. Thanks for watching. Easy Jeezy out.